Hey everyone, and in this video I want to talk a little bit about the calculus and notation as far as what's going to be on the APC exam. Now this is meant mostly for the people who haven't really taken AP calculus yet. However, if you have taken it, there are still some things that you might take away from this as far as expectations. So what are some things that we're going to learn? We're going to talk about how much of the exam is calculus based. We already actually talked about that in the previous video, but basically the a brief definition of derivatives and integrals, notations, and how do we know like the equations that are going to be derivatives and integrals. Again, if you've already taken calculus, I apologize. I'm going to be using a lot of very simplified ways of explaining derivatives and integrals. We already talked about this before about how the exam is really only about 20% of the overall APC exam. So it's not really that major. Even if you don't really have a full grasp of calculus, it's not that bad. You still can, falter on these calculus questions and still have a really good shot at getting a 5 on the exam. But as I mentioned before, the calculus is pretty straightforward. It is very easy to pick up. Now, I keep saying about derivatives and integrals. What do those terms mean? Well, what is a derivative? Derivative in the calculus form is refers to the rate of change of a function based off of its variable. In simpler terms, this is really just the slope of a graph at any point along the graph. Now, we've already done slope before. We've done slope for a flat line and for linear lines. That's easy enough. When we have a flat line like this, we have a slope of 0, so we can also say it has a derivative of 0, that the derivative of the equation of this line is 0. Same thing for this line. This line has a constant slope, and that slope in this case ends up being positive 3. We would say that the derivative of the equation represented by this line is positive 3. Uh, Now, what the whole point of talking about derivative, though, is more for when the slope of our line, or when our lines are much different, when it's curved. Now, how is derivative notated? Now, derivative is notated one of two ways. This is the most common way that you're going to be seeing it, dy over dt. This is usually read as saying the derivative of the function of y uh, with respect to t, or the derivative of y as a function of t. So we're saying that we're looking at how y is changing as we change the variable of t. And there is another thing called a second derivative. This is basically taking the derivative of the derivative. So the second derivative will be written as this, d squared y over dt squared. Sometimes you might see this as off to the side, so you might see it written as d over dt of y, just another way, but this is kind of the more common way that you're going to see it for the APC exam. This is another way you might see derivatives being represented is by these little prime marks. So y prime of t basically is read the same way. It's telling us that this is the derivative and this is our variable. So we're looking at how this term changes as we make adjustments to t. Now, if we want to write this as a second derivative, again, the derivative of a derivative, we would just put a second tally mark, and so on. There are other types of derivatives. There's third derivatives and fourth derivatives, and you could probably already see the pattern of how we would notate it. There are a bunch of other notations, but those are the two common ones that you are likely to see on the APC. Now, why would we use derivatives? There's a bunch of different ways. One is to find another measurement. So for example, if I give you an equation that represents the velocity, you can use that equation to find something like acceleration or the force. Uh, we could use it to find min and max values. Now, realistically, you wouldn't actually do this since you have a graphing calculator. You could just plug the graph into the calculator. But if you had to prove that something was a min or max, what you could do is take the derivative and then set it equal to 0, because that is where the graph ends up hitting a point where the slope, where the line tangent to it is flat. And then the other one is writing a differential equation. Now, for those who have already taken AP Calc, this is actually the one thing that might be different and new for you. So you do want to make sure that you pay attention to my derivatives video, because I will go over what I mean by differential equations. Now, what about an integral? So the integral is the area enclosed by some function within some interval. So here we have two examples. have a graph here, the area enclosed is the integral. So this area between this line and this x-axis and this line and this x-axis and so on, that would be the integral, taking this and adding it all together. Now, one thing to keep in mind is that this is essentially the opposite of doing the derivative. They are opposites of each other, just like how adding and subtracting are opposites of each other, or multiplying and dividing. Just like how if you multiply a number by 2 and then divide by 2, you kind of end up in the same spot. The same thing happens if you take a derivative and then take an integral of that same equation. You end up back where you started. Uh, this is kind of the idea, again, is that you're taking little steps, you're taking area of it, and then you're doing it over a smooth section. Now, how is integral notated? It's usually notated by having this little curl symbol, and then you have your function y, and then you have what you're going to be integrating from, or what the variable is, dt. So this is the variable, this is the function that we're integrating, that we're using, that we're taking the area with, and this is the symbol that we're saying that that's what we're doing. Now, one thing that's missing from the notation I'm showing, and this is more of a limit from the Google Slides, is that I didn't really include bounds. I said before that when you take an integral, it's over an interval, and that's kind of like a yes sort of thing. There is a way to show the interval that you're using. What you would normally do is write the bounds, the low and high part of your interval on above and below this symbol, and that will tell you the bounds that you're taking your area for. Now, when you do that, when you put the bounds, that actually has a specific name that's called a definite integral. And what that will do is that will give you a numerical value. It'll tell you that your area is 5 or 7. Like you'll get a concrete number. If you actually leave, you can leave the integral as unbounded, just blank, and that's usually called indefinite integral, and it basically results in just another equation. So instead of having like x squared, you have another equation like x to the third or something. So when do you use integrals? For the most part, it's pretty much the same thing as derivatives. You can use it to find another measurement. Again, going back to the similar scenario, if you were given an equation for velocity, you can use the integral to find the distance, something like that. There's another one that's deriving equations. Again, if you have already taken AP Calc, this is the part where you're going to want to pay attention. I'm going to be going over this aspect in one of the integral parts, so you want to make sure that you focus at least on that part. Now, what equations use derivatives and integrals? Pretty much a lot of the equations that you work with have a derivative or integral form, a calculus form. Now, all these equations are on the reference table, so it's not like you have to, figure it out. It's not like you're going to be left to your own device on the exam. They are there. However, because of the weird nature of the way it's written, you might not automatically know what equation you're supposed to be using. So what I usually say is just keep in mind what derivatives and integrals are. Derivative is a slope, and when you take the slope of something, you're doing division in it. So for the most part, if you have an equation that has division, that basically means that you can rewrite that as a derivative equation. For example, v equals dt are very common equation for velocity. Uh, because d divided by t is division, this means that I can rework this and say velocity is the derivative of distance with respect to time. So because this is division, it's a derivative. Same thing with integral. When you take an area, you're multiplying length times width, so it's multiplication. So if an equation is dealing with multiplication, that means it could be reworked as an integral equation. In this scenario, I'm using an altered form of with the velocity equation, or the acceleration equation, where v equals v naught plus at. I just dropped the v naught, but in there we have acceleration time being multiplied. So I could say that v is the integral of acceleration with respect to time. So this is a really easy way that if you can kind of look at the question and saying, okay, I would normally use this equation if this was an algebra scenario. Therefore, because there's division, I'm gonna basically take the derivative of the equation, or I'm gonna end up taking the integral. It can really help you save some time. That way, you're not constantly having to like re-look at this reference table. That again could be more distracting. And that's pretty much it. Hopefully, you have a little bit better understanding of the notation and the definitions of what derivatives and integrals are. We'll talk a little bit more in detail about how to actually do them. If you have any questions, feel free to let me know. Otherwise, good luck and have a great day.